Okay, we just finished experiment 1 where we found the amount of data that to load in that's going to actually cause a memory error. So now we're going to start experiment 2. So the first thing we're going to need to do here is actually go with this code one more time, but this time for experiment 2. So this code, what I'm referring to is we're going to again be writing the output of the Docker stats command to a file. So previously we did it to stats experiment-1. Now we want to do it to stats experiment-2. And it looks like I tried to paste it in and that didn't really work out for me. So I'm going to type Control C. And I'm just going to do up arrow and up arrow a few times to the previous command that I ran and just change this to stats experiment 2. It'll probably make it easier for you if I add this here to the file as well. So I'll just add this right here below experiment 2. This will show up in the Jupyter notebooks when you do a git pull. So this will be the code to write the output from Docker stats for experiment 2. Okay, so we've got this here. I'm going to run that, and that is now running. So I'm going to do Control B, P for previous to come back to this window so I can actually see the data here. You actually see we've got quite a bit of memory still being used. I never restarted the kernel after the last experiment crashed. So now I'm actually, let's restart the kernel. We'll reset that. We should come back down to around 111, 112. We are now going to be running experiment 2. Let's do this. Let's go ahead and open up the file that's defining the code we're going to be using. I'm going to open up my file browser here, and I'm going to come to the lib directory, short for library. And here I've got this infrastructure test.py file. I'm going to open that up here in JupyterLab, close this down again. And so here's where I'm defining the functions we're going to be using in this test. So we just used the make and save data set. Now we're going to use do load data and fit and score model, the second function we've got defined here. So this is a function that takes two arguments, a model and a data set name. And so what it's going to do is it's going to load the data sets that we created in the previous step. But now instead of just loading them into memory, we're also going to try and fit and score those models. Fit and score a model on those data sets. And again, we're going to put a 1-second sleep here at the end just to sort of persist for just a moment afterwards, just to register into the Docker stats file that we're creating here. So I'm going to jump back over to our notebook here. We've got this running. You can just verify that. Control B N. Yes, this is running right now. Control B N one more time. This is an available shell. I can actually run commands here. I can do ls here, and I can see that stats experiment-2 is here and is in fact being created, so that's perfect. Control B N to go to the next window, the 0 window, where I can actually see the active Docker stats command, so it's sort of like a dashboard while I'm running these experiments. So first we're going to start with the kneighbors classifier. So let's go ahead and run that. You can see my CPU jumps up, and I'm at about 145 when it's finished. Let's go ahead and restart the kernel and go to the second one. Let's run that. CPU jumps up again, uses about 40% before dropping off. Let's run that again. So one thing that's interesting about the kneighbors classifier is that the fitting of the model doesn't actually really use much CPU. It's basically just loading the data into memory. But the scoring of the model uses a lot of CPU because with the kneighbors model, you have to look at every single data point in order to do the fit. So we just restarted the kernel once more. We've loaded 1, 2, and 3. Let's run 4. There it's going, the CPU jumps up. So K-Neighbors is coming along, it's moving along all right, looking pretty good. Runs 5. Restart the kernel, I'm going to run 6. There it goes, jumps up, and actually hangs there for a second. It looks like with 6, it's actually taking some time to chew through the data, probably at the scoring phase with K-Neighbors. Okay, let's run the next one. Restart the kernel, get down to 0 CPU. I'm at 112 memory usage. Let's run that. We're jumped up. We're at 97, 98%, and it's just running now. With 7, it's actually taking some time before giving us before going back down to 0 CPU. We're at 163 memory, so we're actually this is what I wanted you to see, right? That it's just not an instantaneous process. As data sets get bigger, it takes longer and longer to fit and score models. Okay, so let's restart the kernel one more time. We're back down to 112. Let's run that on the data set of the data set 8. We're up at 99%, up at 200 megabytes. So this is actually doing all right here. This is not really causing any issues. We're okay with K-Neighbors. K-Neighbors is basically, if you think about this, with K-Neighbors, the model is just loading the data into memory. So if we're able to load the data, we're going to be able to fit and score the data. So all of these data sets we were able to load. That was how we got to this point. 9, we tried to make 9, that's when it failed. So since we can load 1 through 8, K-Neighbors is going to perform just fine. All it needs to do is load the data. Okay, this finally finished. So it did actually take a little bit of time to finally finish, but that is it for the K-Neighbors experiment. It looks like all of the data sets successfully loaded, so that's good. So from here, I'm going to leave the remaining models to you to run. You should use the same process that you used on the K-Neighbors model. Good luck.